Coming up on Let's Make It, how you can add peripherals to the Arduino. Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Well, hello there. I am back from vacation finally. Well, technically I'm on vacation tomorrow, but I'm back. And this is Thursday night, and this is the Let's Make It show. And we typically do this show on Monday. So last Monday, well, we did do a show, even though I was on vacation. But we didn't do a very good show. We just did it kind of, we just told everybody know we didn't tell everybody we were going to be on vacation. So this week, we're shooting this on Thursday night because when I got back, over the weekend, I just didn't have time to prepare for a show, and I didn't want to do a flip-floppy show like last week, so I waited a little bit. So I have a lot of things to cover tonight, but I'm doing it solo this week. Bob, who is normally here with me, he's busy. He has a lot of projects going on right now, and between his schedule and my schedule, we just couldn't get together. So hopefully he is back next week, and we'll have to struggle our way through this week kind of by ourselves. So I have a couple things I want to talk about before I get into this week's project. And what we're going to talk about this week is adding peripherals to an Arduino. But before I do, what I want to do is talk about a few things that are going on. And let me get them on my screen so I don't lie to you. Let's see where to go. There it is. All right. So, I mentioned, I think last week with Bob, that I started doing some surface mount stuff, and I'll bring this up on the camera here. And I don't know if you'll be able to see it, but this is my first attempt, actually it's my second attempt at a board. I ruined a board already once. So, but you can see, you may not be able to see it, but there's resistors in here and all that stuff. So, this is my first attempt, and I'm actually trying to flow it. I've seen people solder this, and now that I've seen somebody show me how to do it, I might be able to do it that way, but the flowing is actually pretty easy. Now, there's a couple caveats that I have found with the flowing, and I'm going to talk about that a little bit, and we'll talk about that more as I go through this, because I have other boards that I'm going to start doing this way as well. And the first solder I got, even though it said it was low temperature solder, isn't low temperature solder. It takes over 500 degrees to melt it. So I got it, and I was following instructions. Everybody said flow, and I said they're full of it. They're all lying to me. So I asked somebody, and they told me a different kind of solder to get. So I went and got that different kind of solder, and I got it, and now it works like it's supposed to. So I actually have some video of this process, and I have some more boards coming up. I'm going to do some more video to get this to work, and going to put together a little package on how you can flow your own stuff. And it's actually not that difficult. The most difficult thing for me is these parts are so tiny, it's hard to keep control of them. So I've actually ordered some special tweezers designed for this kind of thing. I've been using like regular tweezers, like I guess you use to pluck your eyebrows, whatever women use, that type of thing. And it doesn't work very well because it sticks to the metal. These other ones I got are fiberglass and supposedly don't stick. So hopefully that makes it a little bit easier. But the hardest part is I didn't bring it in here to show you, but I got this magnet visor thing. And, you know, when you put your finger down there, your finger's like covering the whole screen. These parts you can barely see when you look at them in the bin. So it's pretty interesting, though, to do that. So I'm going to have some videos coming up for that. I did do some recording, and I'll show you some of the results of these boards when they're done. And I have a bunch more of these boards on order. I've redesigned this yet again. So I have some more stuff on order. Okay, so as we told you before, we are developing shields that'll help with these shows. And I'll give you a quick example. A few weeks back, we did an infrared remote. Here's our shield for the infrared remote. We have these in now. we're working on the store portion right now, and we're taking pictures of the products and all that stuff to put up there. So this is our IR remote shield. It's 6 buttons. In our thing we did only four buttons, but I figured I'd add 2 more buttons. That way you had a volume up, volume down, a mute, and a power button if you wanted to actually use it for something like a TV. And if just for learning, it's to use just for learning. So we're getting these all ready to go. We have the boards, we got the parts, and we will start selling these on a store. We're going to call it the Let's Make It store. So that's all coming. So this is that one. One that's coming up that we haven't talked about yet. This is a time-lapse camera controller. Actually, it can be time-lapse, but our goal is to make this a time-lapse, and we're going to show you how you make a time-lapse. So you can take your XLR camera and plug it into this, and say you want to take a picture once a second or once every 5 seconds or whatever, and you can set it up your camera, and you'd be able to like capture a sunset in time-lapse mode. So it's something else that's coming up in the near future. I don't know how weeks out it is. Maybe next week. I don't really know. And then we have a motor controller. And this is a motor controller that can control 2 servos and 2 stepper motors or 4 regular DC motors. So the servos are always there, and then you have a choice between the 2 steppers or the 4 DC motors. And we're going to start talking about motor control very soon. I need to test these things yet before we actually do it, but that's coming. That's what we're going to do here real soon, is a motor controller. And let's see, what else do I have here? Time-lapse, I think it's all brought in. So we have a bunch more boards that haven't made it here yet. Oh, and I have a few testing boards. These are like, actually tonight's show I'm going to talk about peripherals, and this is actually something I probably should have used because this is a great example of how you can use the chip we're using tonight. This is a surface mount chip, and I'm not going to use that tonight. So, but we have a bunch more boards coming into. We have a lie detector, we have an oscilloscope shield we're going to try to make work, and all that stuff too. So we have more coming in the near future. So we have a question for you. We've been trying to engage the audience, get you in the chat room and chatting with us. And this is the show that for some reason I just can't get people engaged. So our guess is we don't know what the best time is to get you engaged. So what I want to know from you, and you can send us an email, or you can actually, that's probably the best way. Just send us an email to let's make it at techzen.tv. We want to know what is the best time of day that you'd be able to watch our show and join in with us. Because we've done a bunch of things trying to get people engaged, get in the chat room right now. And I know this is an off day. We don't normally have a show right now, but we want to know what's the best time for you to come and chat with us. We'd love to have you in the chat room and ask questions and interact with us. Come before the show, talk with us, stay after the show, whatever. You know, it's the kind of thing we're trying to build that community. And this is the show we're having the hardest time building the community. And our guess is that we're doing it at a time that most people aren't available to watch. And if it's just the fact that you like downloading it and listening to it in your car or watching it at work on your iPad or something like that, that's fine. But if you were able to watch it, what's the best time? And we're going to try to pick a time and maybe move the show if there's not people that can come to a common time. So that's just something to think about. Please let us know. Send us an email. Let's make it at TechZenTV. And just make it easier to build the community. What's best for you? So a few other things. We have a Facebook fan page, and we're asking everybody to go like it. We're trying to get the likes built up. It's getting there. I think it's over 200 now, and it's at facebook.com/TechZenTV. You definitely go do that. And we are now going to one. We used to have a fan page for every show. We also went to one single fan page. It's just confusing having all the different show pages. So you can get all the show notes from this show, and you can see all the other shows. We have a lot of great shows. In fact, we're going to start giving some examples of some of the shows on this show. We're going to do like little, I guess you call them house ads, where we show some of our other shows, just to kind of do a little bit of cross promotion of some of our other shows. Going to the single YouTube channel has definitely helped. But if you want show notes from this show or any of the other shows, you can just go to TechZen TV. And the other thing you can do is you can go to Let's Make It.tv. That'll take you directly to the page, the part of the website that deals with just the Let's Make It show. It's like the shortcut to get there. And we do normally record this at 9 p.m. on Mondays. The last 2 weeks have been odd for us because I have been out on vacation for almost 2 weeks. And my last official day of vacation is tomorrow. but we will start going back to our normal time next week. I'm hoping by then maybe Bob has freed up some of his projects, but if not, I'll still be here. Hopefully Bob can join in. Okay, I have one last couple of things. Like I said, we moved all of our stuff to YouTube, this new YouTube channel, and it's actually working out great. We are like 1,700 subscribers already. And if you are watching us on YouTube, please hit the subscribe button, because that helps us build the community a little bit as well. Plus, you get notifications of the playlist if you want a particular playlist that you want to watch. You can also get us on all the podcasting directories, iTunes, Dogcatcher, or any of those things that or podcast lists. We're there. We're pretty much everywhere. And you can get us on the Roku. We are on the Roku app. Just search for TechZen TV and Roku. It's under technology, I believe. I'm pretty sure that's where it's at. And we're starting to use Twitter. We also went to a single Twitter account. We simplified all of our social stuff just to make things easier. But we want to use the hashtag Let's Make It in our show. So if you're going to send us a tweet, just make sure you have the hashtag Let's Make It, # Let's Make It. All right, I'm pretty sure that is it for all of the administrative things. So there's two other things I want to talk about. We have added now a Google community where all of our shows are going to be. So if you wanted to interact with other people that are doing Arduino type work, you can go to the community page. It's done in Google+, so you wouldn't need to have a Gmail account to interact in there, but it's totally free. And hopefully, I know I'm definitely in there already, and I think maybe Bob's in there already, and you can hang out and talk to any of our hosts and other people that watch our shows. And the whole idea of the community is, if you have a question about an Arduino, and it may not just come from us, or like me or Bob, but other people can maybe jump in and help you. You can maybe collaborate on a project. That's the whole idea of building the community, so everybody can get together. So there's a couple of ways you can get to it, but the easiest way is just go to techzen.tv and click on the community link at the top, and it'll take you right to that. And then after you get in there, you join the community, and it'll be just part of your Google+. You can just go to it from inside of Google+. That's the easiest way to do it. All right, so there's one last thing before we get into the meat of today. And that is, you will start seeing, and I'm not sure if it's on this show this week or next week, a new intro in the very beginning of the show, and it's this thing called Alexa TV. And we want to make sure everybody understands what Alexa TV is. So when we started TechZen TV, we started it thinking we would always do technology shows, but we're starting to expand into non-technology shows. And it doesn't make sense to have these non-technology shows on TechZen TV. It seems kind of weird. So we created a new network, and it's called Alexa.tv. So TechZen TV is not going away, but our shows will be still at TechZen TV, but also on Alexa. Alexa is more of a network. So think of it like NBC or ABC. They don't create all the shows that are on their network. Other content producers create those shows for them. So that's kind of what Alexa is. Think of it more of a network, and we're trying to grow that network, and we're going to have shows that are non-technology based, and those will all be only on Alexa, but the TechZen TV shows will still be on Alexa as well. So don't want to confuse anybody. Nothing's really changing at TechZen TV. We're keeping everything pretty much the same. We actually have some new shows coming up we're working on now, and actually we have some of them that are already recorded and are getting ready to come live. We typically recorded 3 episodes, and they're at that point now. We got 3 episodes recorded, and we're going to start bringing them live probably over the next week or so. I think we still have one more episode to edit one of the shows before it goes up. And we have some other shows we want to start working on to create, even on TechZen. So we still are adding more shows in the technology. In fact, if you have an idea for a technology show, definitely let us know, because this is the place where we want to do that. And then if you know somebody who'd be a good host, or you want to be a host, or you want to be a guest, definitely let us know. We are very, very open to all that. In fact, I want to extend this to you too. If you've been working on an Arduino project and you want to share it, there's a couple ways you can do it. You can write us about it, send us some pictures, or you can create a video and send it to YouTube, somewhere like that. Email us the link to it. And if it's really interesting to us, we may want to bring you on to talk about it on Let's Make It. So we can do up to 3 guests at one time. Bob typically is one of those guests because he's located in Dallas, but I can bring 2 other people in, and we can sit here and talk to each other. And it's a great interaction between us because it's live. So, and people can get in the chat room and actually ask you questions. Of course, it goes back to, again, is the chat room. It seems like it's always just a little bit empty for this show. All right. So I want to let's go ahead and move on to tonight. I don't really have any separated segments tonight, but tonight's talk is about adding peripherals to an Arduino. So if you look at this Arduino right here, it's kind of limited in what it can do. This particular one is an Uno, so it has 13 digital ports and 5 analog ports. And when those are all used up, they're all used up. You can't expand it beyond that. So what we're going to talk about, and there's going to be a couple of shows about this because there's a couple of different parts that are very interesting that can help you expand this in different ways of doing it. And I showed you earlier this surface mount board, and it actually is using the chip we're going to use tonight, and we'll be able to explain to you how that chip kind of works. This one's surface mount. I'm going to show you one that's not surface mount. It's the exact same chip, just different form factor. Okay, so there's a couple of things. So if you get this in full and say you want to do more stuff with an Arduino, what do? Well, your one option is you can go and you can buy a Mega. So a Mega has, I can't remember the exact count, I can tell you here in a second. It looks like it has 53 digital ports. Of that, it looks like 11 are pulse width modulation, and it also has 3 different COM ports and 15 analog. So it's much more powerful than that other one that I had. The cost goes up. So this has a lot more RAM. So this may be the other reason you could. That's why I'm using these recently. Is I need a lot more RAM than I would normally use in the small projects we've been doing. I have a project that's quite large, and I just need the extra RAM to put everything on here. So, but if you don't need the extra RAM and you still want to keep this small form factor, what do? So there's a couple options on these Arduinos, and no matter if it's the Mega or the Uno or any of those, there is a busing technology. There's 2 busing technologies. One of them is called I2C, which is what we're going to look at tonight, and the other one is called SPI. Now, they're both serial protocols. I2C can work with 2 wires. SPI requires 4 wires. SPI, if you look at the Arduino and you see on here these little extra pins that most things don't use, and they say ICSP, the SPI is actually located on those pins. In this particular case, there's 2 of them, SPI 1 and 2. And in fact, if you look at, here is a Ethernet shield, and you see the Ethernet shield on the bottom. Let me go over to this other camera. If you look at this, you see the black pin that actually fits on top of the SPI, and the reason that's on here is this particular card has a card reader right here. Well, what you probably don't know is these cards actually read or talk SPI. That's one of the options in most of those cards. So if you have SPI, it's it's literally 3 wires and a very few parts to make this work using an SPI. So that's why that's on there. So tonight we're going to talk about I2C. Now, we've talked about I2C in the past. We've used it for an LCD display. That's how we talk to these serial LCD displays with 4 wires. And the 4 wires are, you have your 5 volts, your ground, and then you have the 2 wires for I2C, which is SCL and SDA. So now with the I2C protocol, if the chip allows it, it has enough space for addressing for 128. So you could put 128 additional chips on those 2 wires. Now, the chip we're going to show you tonight is a 16-bit chip. So it technically is 16 additional digital lines. Where did the Arduino go? And I'm going to attach it to one of these. So this just grew with that one chip by 16 digital I/O lines. And you can put up, and the chip I'm using tonight is actually limited. You can only put 7, or you can put 8 of them in a chain, because it assumes the first 3 bits of the address are always 0. So that is a little limited, but still that's 8 times 16 with 2 wires out of this particular Arduino. So that's one way you can expand. And the SPI, actually the chip I'm going to show you tonight also has an SPI version of the chip that is identical, other than the protocol is different. It uses SPI versus I2C. So you can get the chip in either flavor. The ones I have are all I2C. All right. So there's what we're going to accomplish tonight. We're basically going to add 16 digital I/O ports to this little Arduino. Actually, I have another one sitting here all ready to go. And it's going to be a very simple project. And I actually found a library online for this particular chip, but I had to modify it a little bit. And it seems like any SPI has to be modified slightly. I'm going to go ahead and get this over where it needs to be so you can see it in the camera. All right, so let's go over to this camera. And here's the chip. And the chip we're actually going to look at is an MCP23017. And this particular one is a, let's see how many pins is it. I'm going to walk through here in a second. Anyways, it is 28 pin. And I have it in DIP format here. And you see I have a button kind of hidden under all these wires. There's one button right here. And then there's an LED right here. And I'm basically going to do one example of an output and one example of an input just to show you the results that come back from it. So a very simple demonstration. And if you understand the Arduino digital pins, this will make a lot of sense to you because I've modified the library so it uses the exact same naming convention as it does in the Arduino. So it'll be very, very familiar to you. So let's go. First thing I want to do is I want to go take a look at the actual chip itself, and we're going to kind of walk through some of its actual features. So this is the data sheet, and I'm going to put all the links to this chip. And I got this chip, I think from Mauser probably. And you can, I think it's like $2, $206, something like that, I think, for the chip. So not overly expensive, but we're looking at the MCP23017, and this is the chip right here. So if you look at this, the first 8 pins are the GPIO-B, is what I'm going to call it. And you can see these are in or outs, and it's 1 through 8. So there's the second of the 8 bits. And if you look on the right side over here, you see the GPAs. That's the first of the 8 bits right there. So there's your 16 in or outs. You have your 5 volts, your ground. And in our case, since we're running I2C, we only have 2 wires. So pin 11 and 14 aren't used. If you look at the chip down here, which is the SPI version, you see all 4 of these wires are used because it requires a CS, an SCK, an SI, and SO. So you have serial in, serial out, you're clocking, and you're clear to send. Where with I2C, you only have clocking and data. It's a common bus. So you see we have no connections here. And then over here, you have your address pins. So as I said before, it's 7-bit addressing for I2C. And it also says 7-bit addressing for SPI. They're both 7-bit. This chip only does 3 of the bits. And I'm going to want to get to the next couple pages here. You'll see how that addressing really works. So in this case, you're actually limited, would be a total of 8 because you got 0 and through 7. And our example tonight, I'm actually going to hardwire this for 0. So in our example tonight, I have pins 15, 16, and 17 all going to ground, so it's 0. And then it also has the ability to do interrupts. You can assign 2 different interrupts depending on, it can be a transition or a high or a low condition for any of these pins. And that's something I haven't really tested that, and I haven't had a need to as of yet, but it definitely is in there. And then there's a reset pin, and as long as the reset is high, the chip will work. And you can get in different formats. So basically you see the SPI version chip is identical other than these 2 pins are now assigned. All right, so real quick, you can see here this little dotted line is the SPI and this little dotted line is the I2C. Basically it's basically a shift register, for lack of a better term, but you're not shifting the bits in, you're basically telling it what to do with the bits. So it works in a similar way as a shift register we've done in the past. But it's not daisy chainable, things like that. I mean, you can put all these chips, you can put, like I said, 7 of them together, or 8 of them together, and you give them each a different address. But they're all listening to the same thing all the time. Okay, so let's come down here. Let's see. Just give some basics of the bidirectional. Oh, the other thing is it can also have a pull-up resistor like the Arduino does. So you can pull up without having to do any additional resistor for buttons, so they're not floating. Now let's get down here to see where. Okay, so in general, basically, do is you send this thing. You configure registers. So you give it the address. So here's the address 0000 gives you the input-output direction for A. And then here's 1001 is the input-output direction for B. So you can see how this addressing kind of works. I'm not going to go into great detail. In the library, if you look at it, it actually explains a lot of this. And I've added some comments into the library as well. So you can see here we have also, you can read and write, and you're going to see that tonight. And then you have, let's go SPI, we're going to skip over. I want to get to the addressing. All right, so here's the addressing. So in this case, they have hard-coded into the chip 0100 and then your 3 pin settings. So if in my case, I have them all set to low. So my address is going to be 0100000. And that's the address I'm going to set it to, is 000. So it's exactly the same way with SPI on this chip. And that just means you're limited on what you can do. Now, some chips that are I2C, which I plan on doing more chips on the I2C and SPI both, because we have a lot of things you can control using both of these protocols. So I'm going to discuss that in future. There's a lot more things you can do other than just basic I/O like this too. I want to talk about some of the other things you can do with these protocols, with other kinds of chips out there. The other one I want to show probably in the next couple weeks is an LED driver. So we've done a lot with LEDs, and this driver will do a lot like, if you remember the 7-segment display where we could turn things at different brightness levels by PWM. I have another driver chip. I think it's 16 LEDs it can drive, but it's also PWM. So you can do a lot of things with it, and it's all done through SPI instead of using a shift register. So it's just another way of doing it. So anyways, that's the addressing. So, and it's important to know that I have wired this to 000 in the actual design. Okay, so let's see. I think that's all I'm going to cover. Well, no, I'm not going to cover. So here you see us. Here's where you can go and you can set the different directions of each of the pins. These are just the details of the registers that I mentioned before. Input polarity. Let's see, there's also interrupt on change. I mentioned about interrupt, so you can set any of these bits to true, and it will give you the interrupt whenever these pins change. Let's see. All right, there's default values. Another interrupt on change. That's pretty much, oh, now we're getting into configuration. I'll put this link to this data sheet. It's actually, if you're like reading data sheets, it's actually a pretty good one. There's pull-up resistors. So here's your eight bits for which pins and pull-up resistors. So yeah, it's all in here. You can see it's all in here. All right, so let's go ahead, and what I want to do is get up the code, because this code is actually very, very simple. Let's see, where is it? And I'm going to go ahead and I'm going to plug in and let you see what it's going to do, so you can kind of get an idea of what this is all going to do. All right, let's go look at the board. Okay, so you see the green light there flashing, and it's actually flashing, I think, about once every 100 milliseconds, if I remember correctly. And there's a button here, and the button doesn't do anything physical on the board. It does something in our serial monitor. So we go back to the computer here. I'll bring up the serial monitor, and you can kind of see what it's doing. Let's see, Tools Serial Monitor. All right, let's go back over to the computer. Okay, so what you're seeing there is 0101010101. The reason you're seeing that is that light is turning off and on. So I am using a function that basically gets the status of all the pins. Well, that pin's going on and off to turn an LED on and off. So when I push the button, you see it going on and off, 256, 257, 256, 257. So the reason that is every bit, with the LSB bit being the high end of B, which is basically B7. So if we go back and look at this drawing, I'm sorry, it's B0. B0 is where I have the LED. So you see, I'm turning it off and on. So this is bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, and then it's bit 9, which is the value of 256. And that's what you see if I go over here and look at this and I hold the button down. You see 256 and 257. So you see the pin 1 is flashing right there, and this is pin 1 still flashing, but it's I'm been holding the button down on bit 0 of the A register. So let's go look at the code though, because the code is going to help explain a lot of this. So we have to include the wire.h, and then you include this library. Like I said, I've modified this library pretty extensively, and I've renamed just about everything in there, so it makes a little more sense. This boolean is basically the current LED state. It's either on or off, true being on, and you'll see all I'm doing is flipping that around every time it comes around. So I basically define the chip, and I'm calling it GPIO chip, and it's I define the class, and the name of the class is GPIO chip. And then in setup, I'm setting the serial monitor, saying serial started. I begin wire, which is required. And then I'm going to set my chip. I'm going to start with the chip. And when I do that, I have to give it what address I want. So I want address 000. And then I knit the chip. And then I set my pin mode. Just like you do in the Arduino, you just set the pin modes. So here's pin mode. My very first pin, which is controlling the LED, which is pin 0, which is B0, is set to output. All the other ones I set to input. But I'm only really going to use pin number 8 as an input. So we set our inputs up. This is very similar to just like you would do in Arduino. And then here's our smaller loop. So, and I'm going to modify this real time here just so you can see some of this. There's a function called digital word read, and what that basically is doing is, and I'm going to show that to you this way. Let me put this in here. So I'm going to show you what bits are coming back. Let me upload this. And I'm going to run the serial monitor again. Okay. So that is, look at from the point of view of bit. This is the LSB bit of 1. This bit over here is the button that I'm pressing. So if I would move, let's say I would move that down to the bottom. I'm not actually going to do that. I'm going to move the button to the highest bit in register A. So I move this. There we go. All right, so now you should see the whole thing. So there's all 16 bits. And you can see the one on the left is the button that I'm pressing, and the one on the right is the LED turning off and on. So that's what you're getting back, basically, from this word read. So you think, well, that's not easy to understand. So yeah, you're right. But if you look down here, here's digital write, right here, GPIO chip, digital write, and I am writing to pin 0, and I'm doing the opposite of whatever the current LED value is, and I did not reverse it. So just like you do with an Arduino, it's digital write, and we can also do digital read, and I am currently on 15, I believe. And actually, I'm going to do a print line. If I do it correctly. All right, let's put this out there. All right, bring open the serial monitor. Okay, so here, let me do this. Let me get rid of this other one. just so it's less confusing. And we'll go back to the serial monitor. So now what you're seeing is the state of that one button. So I'm going to push the button. There it is. You're seeing the button state of that one particular button and not only that button. So just because you can do a word read doesn't mean you have to use it. The functions exist to be able to read just like you do in the Arduino. So I have just added 16 more inputs and outputs. Now there's no PWM on this. It's only a digital input and output chip, kind of limited in that point of view. But if you think about it, this is kind of how if you remember the SPI that we did with the LCD monitor a while back, this is kind of probably what it's doing. I mean, it basically has a chip very similar to this, more specified probably to running the LCD display, but it allows you to use an I2C interface using only 2 wires and to control, what is it? Well, if you're using an 8-bit LCD, it's 11 wires. If you're using a 4-bit LCD, then it would be 7 wires. So it allows you to do it with just 2. So in some of those chips, like this one has the ability to do 16 inputs and outputs. The LCD only needs 7 of them. You can use the other ones for keypad input, all using just 2 wires. So it's a really easy way to expand the capabilities of an Arduino, and you can expand the capabilities of an Arduino that is small. A small Arduino, just like this Uno, can now expand out considerably. The other thing is, if you have peripherals that are farther away than where the Arduino is located, so you have a project and you have some little bit of distance between them, you use the SPI and you get to this other location without having to run a whole bundle of wires, however far the distance is. Makes it a little bit cleaner to do some of the wiring as well. So that's just some of the advantages to using an SPI, or not SPI, but I2C or SPI. And there's plenty of other protocols too. There's CAN bus, and we may talk about some of those other protocols as well. Actually, I think I have it in my list to talk about, like RS485 and CAN bus and some of the other protocols that are out there as well, and integrating them in with an Arduino. It just happens to be that I2C and SPI are built right on the Arduino, and it's very easy to plug it in. You see, if you actually go and you look at this, actually, let me turn off the blinking so you can see. I only have a couple wires running. I have power and ground, and then I have 2 wires, and I could run all 16 of these pins all over here just off of those 2 wires. So it does definitely save on some wiring as well. And then I still can use the other pins on the Arduino for other things. So I basically have expanded to the Arduino to be something that's a little bit bigger than that. Now these protocols are very, very common around on many chips. In fact, that's kind of why I think I maybe do some more episodes on I2C, because when I start looking for stuff that's in I2C, there's a lot of it and a lot of neat things you can do with I2C. All kinds of different sensors. In fact, I just got a sensor pack. I haven't opened it up yet. It's like 37-in-1 sensors. I know I did a whole episode on sensors before, but this is a whole other set of sensors, a lot more types of sensors that I haven't played with before. I'm looking forward to that. And some of them are either SPI or I2C. I think they're mostly for the most part I2C. But there's all kinds of cool things out there that can be interfaced with I2C. Some of them, like this particular chip, is a little bit complicated. But when you figure out one, they all work the same, because SPI is SPI and I2C is I2C. You just got to know what register does what, and you can pretty much take the same library you have for one, copy it to another, and just make some minor changes as far as options and stuff to set up. So that's kind of what I plan on doing with this particular library that I just modified. It just had a few little bugs in it and did something I didn't like, and added a couple of functions and renamed things so they were exactly like the Arduino, because they weren't named the same. And I think it's easier if you already know the Arduino to understand how to use it with things you already know, the names you already have there. So that was the whole purpose of that. All right, that is all I wanted to show for this week. And like I said, I'm going to put all the library and all the notes and everything and the links to the chip on the show notes. And I'll even put you a link to Mouser where you get the chip, wherever I got it from. I think Mouser is probably where I got it from. That's generally where I buy the bulk of the chips that I get. That or DigiKey are typically where the 2 places that I get them. And I generally buy them in bulk, so the price I gave you of $2 might have been like for buying 50 of them. I don't know. I have. 'Cause I'm gonna start selling these in the store as well, parts like that. So you can, if you did a project and you want to maybe do another project, that'd be something to do. So before I let everybody go, we are talking about doing some projects. Now I have a couple of things that I've kind of wanted to do, besides the fact that I'm working on this project, but more fun type things. Well, this is fun, but like around the house type things. I want to build this little thing, like a button, because when my dog needs to go out, she just comes and stares at you. But if you're not paying attention to her, you don't see it. So I want to be able to go hit the button, see if I can train her to hit the button when she wants to go out. So that's a project I'm going to want to make here soon. In fact, I have the big button thing coming. And the other thing is, we have a bad habit of leaving the garage door open at night sometimes. We're getting better at it, but we used to have this thing when we moved into the house that a light would blink on saying the garage door is open. Well, it's been broken for 6 months or more. So I want to build some kind of, I'm probably going to use Zigbee to transmit into the house saying the garage door is open. And it sat in our kitchen before we go to bed at night. It would sit there and it'd blink and say you got to close the garage door. But as I said, it's been broken. So I'm going to take it and do a two-way with it so that we can maybe close the garage door from in the house. So that's something I'm going to look at here, maybe as a project too. But these type of things, projects like this, we want to maybe turn them into like segments of a show. So we'll do a little recording episode and we make these projects and put them on Let's Make It. So I'd kind of like to know your ideas for that. If you have an idea for a project you'd like to see made, we'd love to hear that too. Maybe we'll make it more of a on request type of thing where you need something made and you're not quite sure how to do it and you want us to do it with you. We'd be happy to do that because that's all fun for us. So definitely let us know. Just send us email to letsmakeit@TechZenTV. I do want to remind you that you can friend us or follow us on Facebook. It's facebook.com/TechZenTV. And definitely go do that. We're trying to get that built up. It's something that's kind of new for us. And we'd love to have you on there as well. All right. I think I've pretty much covered it all. Don't forget to let us know what is the best time for you to watch our show, because we would like to get this to be a more interactive. And if this time does not work for you, we normally do it on, like I said, Monday nights at 9 p.m. You can let us know what it is, and if we can get a consensus of a better time, we will move the show to that time, if it's possible for us to do it as well. But we definitely like to know. Again, send us email at letsmakeit@TechZenTV. And be sure, if you tweet about us, you use the hashtag #LetsMakeIt, because in the very near future, we probably are going to have a competition around that Twitter hashtag. I don't know, maybe we'll give you something away for free. We'll have to see. Maybe you guys come back and find out. All right, that is it for this week. We will be back Monday for sure next week. Well, I don't want to say that because I have to break that promise, but I am officially back from vacation on Saturday. Well, we'll say Monday for that one too, but I am actually back now. Even though I'm not going to work, I'm just using the time to kind of relax before I get back to work. But everything should be kind of back to normal next week. And well, hopefully Bob has loosened up his schedule a little bit, and maybe we'll have him back next week. Looking forward to having him back. It's nice to have somebody to talk to. All right, everybody. We'll see you next week. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.